And we'll go ahead and get started. So welcome to our newest episode of Intersections. If I could please direct you guys to the Google site. It should be on the screen right now, the link right there, but you can also find the link down there in the chat that you'll be able to click on. So I'll direct everybody to the Google site, and then we'll be able to interact from there. Last month, Jennifer Brackney was the host, and we're still working out a little bit of technical difficulties, but actually like 18 people logged in and viewed that session on the hub. So I can tell that there are people that are interested in this, and we are going to proceed. We're pretty excited here. So 500 billion.
Okay, so then you cut that in half, right? This is what I was kind of looking at. So then you're 500 billion, so then half of that. So you'd have to keep halving a whole lot, I think, right?
Yeah, so you're at 500 billion, 250 billion.
And then 125, right? And then 62.5, then 30, and then half of that would be like 15.
So it's kind of a fun problem. I don't want to spend all of our time on it, but I think both of you guys are both correct, both on the right path. It's just a fun problem with place value since we don't work on billions and trillions that much. That a trillion is 1,000 billion. So really, it'd be 1/1000th of that line. So very, very close to one, and that's why the national debt is so scary because. Once you start thinking about place value and how much money that really is, it's pretty crazy. So let's go ahead and talk a little bit about GeoGebra. So Rusty, why don't you go ahead and introduce yourself and just say how long you've been teaching, why you like GeoGebra, and then I can make you the presenter and you can go ahead and go into your presentation.
Okay. Yeah, as Jake said, my name is Rusty Bowers. I'm currently at Fort Benton Schools. This is my second year here. I am now the high school principal. I'm also teaching 2 high school math classes right now, and I'm also our tech coordinator. Keeps me pretty busy around here. I used to coach football. I took the year off due to my principal role, but now I think next year I'm going to jump back in and do some coaching and stuff. But this is my 10th year in education. I spent my first 4 years as a high school math teacher in Sheridan, Montana, and then 4 years in Belgrade, Montana, and then this is my next 2 years here in Fort Benton. So that's my 10 years. Always been a high school math teacher, but as far as my GeoGebra experience, I absolutely love GeoGebra. I use it every day. We're actually now one-to-one with Chromebooks at our school here, so it's been great. We've been on Chromebooks and GeoGebra in my 2 classes I teach almost every day, doing some fun stuff. But I got my interest, or I found out about it in my undergrad at MSU. We started playing around with it. That's about when it came out, GeoGebra. And then when I was teaching, I always had a smartboard, and so a smartboard and GeoGebra worked really well together, I thought. So I've always just kind of been playing around with it. And then I got my master's in math ed and from MSU, and we use GeoGebra a ton in that program. And so just I think all the exposure and all my practice with it, I got really comfortable and started, I was Googling code, GeoGebra code on how to do my own things, and I've made some really, what I feel, some pretty cool things with it, and done some exploring, kind of played around with, like Jake and I were talking yesterday, doing some lessons where GeoGebra is really good, and then I do lessons where GeoGebra, I think, isn't benefiting the math concepts. I don't know if that makes any sense, but
yeah, no, that's great. And I've actually got a pretty good example of an example that I pulled up earlier that I was kind of excited about because I was looking for a younger grades example, and Rusty quickly reminded me that I was being a knucklehead. And so we'll talk about that. But Rusty, I've made you the presenter. So why don't you go ahead and open up
share my screen?
Yeah, whatever you got to do.
You guys see my screen now?
Yep.
Okay. I don't know. Is there any way? I think we only have 2 people on.
There's Jennifer. There's an LS.
We have a waiting name here.
There's a bunch of waiting for names. One of the waiting for names just left, so we just scared him off with that one.
Well, there's a couple like offline. So, or maybe on our document, Jake, is there a way that we can put if they're experienced with GeoGebra or not?
Yeah, we could do that. So why don't you just scroll down and then under GeoGebra presentation, say what is your experience with GeoGebra, and then you guys can just go ahead and type in whatever that experience may be. So I personally have seen Rusty do a bunch of stuff. Oh yeah, Jennifer's still on too. And just to reiterate, even if we have few numbers on this, we did have like 18 people earn OPI renewal hours by watching Jennifer's presentation from last week. So we're going to keep on going. Jennifer's seen GeoGebra.
Okay. Now, as you guys are typing, I just want to let you know too. I'm a high school math teacher, so looking at, we have an elementary teacher here, and we probably have some more elementary teachers. My first example is going to be like an elementary concept, and let me know too after I go over it if this is beneficial or not. I guess it's kind of hard to wrap my brain around the elementary standards, and I haven't really looked at them. So seeing videos on the hub. Okay. Alicia's got very little experience. Great. Okay, well that just kind of helps me out of how to go about this talk here. So the first one that I'm going to do is an elementary standard, and so what I found, I just took a picture here of our state standards. This is a 3rd grade overview. So I chose the standard 3 here. So developing understanding of the structure of rectangular arrays and of area. So I thought maybe that might be a pretty neat conversation to have using GeoGebra, because I think I can imagine something that I can make. But what we're going to do is use the idea that area is the number of squares as a unit of measurement, and kind of get to this idea that it's really like the length times width, right? When you multiply 2 numbers, that product can be represented as an area. So I don't know if it works with these intersections here, if you follow along with me or if you just watch. I'm going to just start from scratch here, so I'm going to go File, New. So when you, I'm using the desktop version here of GeoGebra. It's a lot like the app version. It's just that on the desktop, the input's down on the bottom, and on the app, your input looks a lot like Desmos if you've used Desmos before. But the input is over here on the left. So by default in GeoGebra, you get the axes that always kind of come up. If you want them, you can just keep them there. But if you don't want the axes, you can always hide them. So we can just have a blank screen, blank plane. Or you have the grid lines too that you can turn on and off. So it's nice in GeoGebra, depending on what application you want to use it for. You can turn your axes on and off. You can turn your grids on and off. So for this first example, I'll have my grid lines on. Since we're talking about rectangular array, the coordinate plane is good to have. Some basics about GeoGebra real quick. These icons up here are called toolboxes, and every toolbox has these little arrows that you can click on, and you're opening up different toolboxes. So for example, this toolbox is the point toolbox. So when you get familiar with GeoGebra, anything that relates to a point, like we can just put points on our screen, we can find intersections of objects, and it'll put a point right on the intersection. You can find the midpoint or center And then I haven't really done a whole lot with these ones. But then you've got the next toolbox is your line toolbox. So really any part of a line will be in this toolbox. So you can do a line, you can make a segment, you can even do a segment if you know the length of it. You can make an array, which is like half of a line. Haven't played with the polyline very much. The vector, you can make vectors and whatnot. So all these different toolboxes, transformation toolbox. So again, if you're elementary, I'm not sure if you guys go into the realm of perpendicular, parallel, but these are things that we can make with like a compass or a straight edge. The polygon toolbox is a good one to use. I'll play with that a little bit. You can make circles, and you can measure. This toolbox here is your measurement toolbox. So there's lots of things. The more you explore and play around with the toolboxes, I think the more this will make sense. So I'm going to go ahead and take a look again at the standard real quick. So again, we're going to make a rectangular array, and we're going to use area to do that. One thing that I really like about GeoGebra is depending on the type of question that you want to ask kind of sets up how you're going to use GeoGebra. Okay, so what I mean by that, I'm going to show you like a rectangular array problem one way, and then I'm going to use what are known as sliders. This is what's nice about GeoGebra, is being able to slide values so that we can set some dimensions versus just creating a rectangle. So I think that'll make sense in a second. Again, elementary know how to start this. I'm just going to start talking, I think. But what I'm going to do is use the segment tool to start with. So I'm going to just grab my segment tool, and I'm just going to make a rectangle. So I'm going to just use the coordinate system here and just make a rectangle. Say like that. So depending on where you would be at in your math lesson, we could talk about the area covered by this rectangle, where I think what that standard is talking about rectangular arrays and then counting them up the arrays. The idea here, though, is that we have some dimension, getting our students to know that it's this dimension times this dimension gives us the area of a rectangle. So just using the segment tool, you can just construct a rectangle. And then the problem with this, though, is if you want to change some points around, then we have to just move all the points for the next example, which is kind of cumbersome. So there's different ways that we can make rectangles. We can do, let me think here. We can make a segment, and what I want to do is make a perpendicular line, right? So I know that in a rectangle we've got 4 90-degree angles, so maybe what we can do is grab in our construction toolbox here, we can just make a perpendicular line. So I'm going to click on this point right here, and then I'm going to click on the segment that I want to be perpendicular to. So I'm going to click on this segment right here, and now I have a perpendicular line. And then I'm going to do the same thing down here. I'm going to click on this point F, click on this segment here. I got my perpendicular line. And then what we can do is we need to get this fourth side made. So what I'm going to do is grab my point tool and just stick a point on one of these lines. It doesn't really matter which one. So I'm going to stick one right there. And then I need to create this fourth side. And so I'm going to just stick with the perpendicular thought here. So I'm going to click on this new point G, click on this line here, and now I have a perpendicular line. And so I hope you guys can see the rectangle that's being built. And then I'm just going to grab my point tool and stick a point right on that intersection. Okay, and what's nice about that is now when I slide things around, this thing, no matter what, you can even tilt it too, this is going to stay a rectangle because I use the perpendicular nature of a rectangle to construct this thing. So if you just use segments and you want to make different examples, The segments are nice for like one example, but then again, when you want to move things around, you have to click a whole lot, versus now we can just change our rectangle and make lots of different rectangles. Okay, so that is one nice thing about GeoGebra, is being able to do a whole bunch of examples without doing a whole lot. So if I was teaching elementary and I'm going to use this rectangular problem, I would have this rectangle set up, and in all reality, we really don't have a rectangle. We just have a segment and a bunch of lines, and we can see a rectangle in here. So it might be good for like our students if we actually construct the rectangle. So nice thing about GeoGebra is you can hide and show objects. So like my lines in the algebra window over here, the algebra window shows us all the objects that we've made in our graphics view here. So I have all my lines, all my points, and some segments. So I know that I want to hide these lines, and then I'm going to just use a segment, or maybe even my polygon tool to make the rectangle. So to hide objects, you can click on these little purple dots over here for any object that you want to hide, or if you want to show them again, you just click on them and you can quickly hide and show things. So now I have my 4 vertices of my rectangle, so I'm just going to come back and show you the polygon tool. This is a pretty neat tool because I can click on my 4 points, I can make a rectangle, and now I've got a polygon here. You can even shade it, so it's good for kids to see, you know, the area that it covers, and then you could even make it a little bit darker. So the polygon tool does a lot of things. It shades the interior of a polygon, and you can see, like making it darker, I think it's good to see the, you know, the area covered by this rectangle. But another nice thing that you can do with the polygon tool is you can actually measure things, like you can measure in the measurement toolbox. We have an area tool. So this is nice. You can just click on your polygon and it'll tell you the area, which is weird that it's 44.9. There we go, area 40. So again, using the polygon tool, it'll make a polygon and you can measure things like area, and we have a distance tool. So if you wanted to show, so the distance or length, if I grab that tool, I can click on a segment. It'll show me, I don't know if you guys can see that. It'll show me the length of the segment. So if I click on all of these segments here, it can show me those sides and their length. And again, as we move things around, it'll just correspond to our rectangle, show dimension. So again, you know, depending on your conversation, you could talk about the array, whatnot, but get to the idea that it's really, you know, this dimension times this dimension is the area of that rectangle. Okay, and then the other example I wanted to show you too, to stay on this kind of topic, just to kind of show you again, I think the idea is just to show you some cool features of GeoGebra, is using sliders. Sliders are a cool way to create a variable and give it value, I guess. And you can create a range that you want the variable to be. So what I mean by that is I'm going to click on my slider tool and I'm going to just click somewhere on my screen and I'm going to place a slider. So since we're talking about a rectangle, we might want to use like length and width or base and height. Maybe I'll use base and height. So this first slider I'm going to use is going to be for my base, so I'll call it B. With sliders, you know, you can change the minimum value. So in a rectangle, we probably want a minimum of maybe 0 or 1. We'll go with 1. And then we can make a max. We can make this thing up to however big we want. So maybe I'll make it 20. And then as we slide the slider around, it'll jump by an increment. And so since we're elementary, we probably want to jump by 1s. And then I'm going to click OK. So now I have a slider here for a variable B, and I can slide it, and it's just going to give that variable B different values. And then I'm going to do one more slider for like my height. So I'm going to call this H, and I'm going to do the same thing. So I'm going to make my height go from a minimum of 1 and a maximum of, say, 20, jumping by 1. Okay, so I got my base and my height. So what I think is kind of neat about that is we can start playing around with, like, we can use the segment with given length tool. So if I make a segment of given length, I'm going to just click to make an endpoint, and then it asks me, well, how long do you want to make the segment? And I'm going to make it, I'll make this like my base. So I'm going to call this B, and I'm going to click OK. So here's my segment, and now since I made it B units long, when I move my slider, I can change the length of that segment too using a slider. Okay. As I'm talking and I'm thinking about constructing this rectangle with these two sliders, it's going to be, I think, to make an actual rectangle, kind of an involved process, but maybe if I use the segment given length tool again and I click on this point, I can make a new segment with length H. Click OK, and then I might want to take this and I can rotate it down here. And now I have a different dimension that we can change as well. So I kind of want to just show you the feature of sliders in GeoGebra. So there's different ways that you can manipulate segments and objects and numbers by using sliders. A pretty cool tool. So I hope that made sense. I'm not sure.
Oh, yeah, no, Rusty, that was great. One thing that I also liked about this, too, is, you build those rectangles. And so you've got that 13 for both your top and bottom there, then your 5. I mean, this just lends itself so well towards the area model of multiplication and distributive property. And so you could draw, a secondary, rectangle over the top of that, and the kids can see that, oh, 13 is actually equal to 3 plus 10, or, whatever the heck, however the heck you wanted to split it up. So.
Oh yeah, like talking like distributive property.
Yeah.
What you're saying?
Yeah.
Yeah. So I think that'd be kind of neat. You could do, yeah. Whether you want to, I'm going to just kind of lighten this because I'm going to put another polygon on top. I'm wondering though, as I make this, if we have to do the rectangle thing, but I'll just do one example. So this might be kind of what you're talking about, right? Like, here's a new polygon. Maybe I'll make this one red. So kind of like what you're saying, right? Like, here's our here's our dimensions now, right? So like Jake was saying, you could look at this rectangle here. It's got a total area of 65, but now we can look at this as decomposing into two different rectangles, two different areas, and kind of get that distributive property going. So yeah, that's a pretty neat way to do it.
Yeah, so Rusty, for someone that wants to try using GeoGebra in the classroom, like, what's a good first step? How do they say, all right, this is something that I want to make happen. What do I do now?
There's actually a manual. I'm trying to think. Maybe I can search for it real quick. So if you were to just Google GeoGebra manual, I believe, and it's a PDF. This is a good place. So whenever I do like trainings on it, I'll always kind of reference this manual because it's really nice, and it does. There's actually a couple. This one here, GeoGebra, where it's GeoGebra 10 lessons, is a good one, and what it does is it has 10 GeoGebra lessons that kind of start very basic, so getting to know the environment. I'm just going to scroll down here. So it talks about the environment, like shows you, the algebra window versus the graphic view, your input bar. It breaks down the toolboxes and some of our menus, what they do. So this is a great way to kind of get yourself familiar or have a key of what's in your different toolboxes. And then it has step-by-step instructions on how to do certain things. So like this first lesson is to construct a triangle and measure the sum of the interior angles, for example. So it's a good step-by-step to show you how to do that. And then as you move, go through the lessons, you just pick up more and more tools. So I think people that want to give it a shot, this is a great place to go so you can get kind of familiar with it.
Cool.
Another nice thing I just want to show you real quick is if you use the app, so I've got the GeoGebra app right here, you can, I'll let this load. Okay, so you can go to Open over here, so the three lines over here, I don't really know the name of this. I call it the Options menu. Maybe that's what it is. But anyways, click on the three lines and then click on Open. And the app is all internet-based, right? So I've made a lot of stuff in mine, but there's some cool lessons here. And you can also search. So maybe if you want, like, area, for example, you can also search for pre-made lessons.
Oh yeah, that's cool, and they got the 3D shapes and everything there.
Yeah, and so these are made by other people that have shared them. So I've noticed, though, that sometimes people do a really good job in describing what the app does, and then some, like mine, I just make them for my class, and then I explain it in my class, but I bet if somebody found it online, they'd be like, what the heck is this thing all about? And I think that's what some of these other ones are about. So you kind of have to go hunt and find things that you like.
That brings up a pretty good point of making sure that you pick quality lessons. I went out on the internet and I just kind of did a quick Google search, like GeoGebra lessons for early elementary, because to me this is very naturally fitting into like a geometry class, but I see the power there, and so I was like, I'd like a great example of how would this fit into a early elementary class. And so Rusty, if you don't mind, I'm going to just share my screen again. So can you guys see those shapes up on the screen there? Is that showing up?
I can see it, yeah.
Okay, cool. So I got this lesson, and I was really excited about it because I was like, oh, look, there's these shapes, and it says use segment between 2 points tool to divide each of these shapes. So then I was showing Rusty this because I thought it was so great, and you can draw something in here like this and draw something in here like this. And like on the surface, like, yeah, this is like going to, but then look, oh my gosh, all of a sudden I'm drawing these like, I didn't even mean to do that, these goofy line segments, and all of a sudden this is really distracting, and Rusty asked the question like, why wouldn't you just do that on paper? And that was kind of an aha moment for me of, oh yeah, like GeoGebra is powerful and GeoGebra is great, but let's use our heads about this and don't use GeoGebra just for the sake of using GeoGebra. Let's use GeoGebra to make our classrooms better. You know what I'm saying there, Rusty?
I do. And for this app, so like when you find things online, like Jake found this one online, it only has 3 tools in it, right? You have the arrow tool, you have the segment tool, and then a delete, or like garbage can. But I think, though, that if you made this, depending on what lesson you want to do, like what if you were talking about trying to divide into equal force and using area, right? Like if they're equal force, they should have the same area. So you could, if you were to make this maybe on your own or find one that has all the tools. So as Jake was doing this, I just kind of came to my mind. But like I look at this plus, like it's really a cool math question of dividing into equal force, or even this little staircase looking one. But you could use that polygon tool and then just and measure the areas of your different polygons and then try to make your areas the same. You know what I mean?
Yeah, so using the GeoGebra to actually measure the area instead of just eyeballing it?
Yeah, because I don't know. I mean, I think eyeballing it might just be as easy as using paper. Because like these shapes don't really change. So that was just a thought.
Yeah, great. Go on.
And just one more thought, too. It's nice about GeoGebra, too, because you can extend questions. Like, as I'm looking at this problem here and I'm thinking about area, and maybe like that octagon looking one in the bottom left, you could divide that up lots of ways to be, in a force. So you could even just say, find more more ways than one, which that would be nicer than having a sheet of paper. Do you know what I mean?
Yeah. Cool. So there is potential. Just make sure you're thinking about it when you're picking something there. So
Right.
I'm back on the Google Doc. I'm going to invite you guys. Rusty, do you have anything else crucial that you wanted to share before we open up for questions?
As far as examples,
Yeah.
can I show one more example? It's kind of cool.
Yeah. Yeah.
Man, I thought Chris is on board here. Okay, so let me take over. Okay, so the other one that I have real quick, this is kind of a fun problem. So we're in Fort Benton here. What I did was, a nice thing about GeoGebra is you can insert images. So I went on to Google Earth and I found, this is our Fort Benton High School Google Earth picture. So this is like more of a middle school question, I guess, but what's the perimeter, in whatever unit we want, maybe square feet or something, of our school grounds, right? So for like our school grounds, and it depends on how well a kid wants to do this, but just for my example, I'll just make my segments here stick out a little bit. Maybe yellow will stick out. But maybe we want to find the perimeter of this. So the reason I thought of this is because I was looking through middle school standards and I saw proportion scale factors, and you can tweak this around. But the idea that I just wanted to show you, is, it's kind of nice to be able to take a picture like this and think about scale factors. So the reason I chose this picture is because there is something in this picture that we know, at least I think we know for a fact, of an actual length, which this is our football field. So this picture was taken before the lines were put on there, but we have 2 goalposts. So in Fort Benton, we're 8-man football, so we have a 80-yard field. So really from, goalpost to goalpost, it's really 100 yards. Is that right? 80, yeah, 10, 10. So think about that. So I know that if I want to say feet, for example, then from goalpost to goalpost, I actually know that that measurement is 300 feet. So then I can grab my segment tool and I can stick a segment right here, and it actually tells me how long that segment is. So using proportions, we now know enough information, I think, to find the perimeter. So I'm going to just grab my pen tool, and I'm just going to write over here. I know that a segment that's excuse my handwriting, this is with my mouse, 4.34, is really equal to 300 feet. And now I have my scale, right? So now we can start doing things. So we can find the length of all these segments, and we can convert them to feet, and then you can figure out the perimeter of your school. So I just wanted to show that quick example because pictures are something that's really cool, and one thing that I find really powerful is being able to take a picture and then do math on top of it. And then really what's neat too is you can just hide your picture and we can talk about, just the general math, right, depending on whatever conversation we're having.
That's cool.
So I just wanted to share that, Jake.
Yeah, no, I really like that. Thank you. Any other ones? I mean, we're pretty well out of time once we have questions and everything, but I was almost going to rush through that one, and I felt it was so great I would have been doing people a disservice. So.
No, I'm good. I mean, if we got questions, we can answer.
Okay. No one's actually typed anything into the question box yet. So we've got questions about GeoGebra, and we've got questions, other questions or comments about math education in general. So maybe something that's going on in your classroom or a question about GeoGebra, feel free to go ahead and type those in right now. While you guys are typing, I would remind you guys that there is a GeoGebra Hub course. So basically what we did today, but more in depth, more opportunities to earn renewal hours. And what it is Rusty actually does a great job looking at smarter balanced items and NAEP items. And then he deconstructs those and says, this is how you could teach it using GeoGebra. So great way to get more lesson ideas. And I think that, Rusty will be able to share any of those questions with you, or any of those, lesson templates, or help you set them up if you needed more support moving forward with GeoGebra. So that's
and also feel free to, if you want to email me too, you got my email on this document. So if you are playing around and you have a question, feel free to shoot me an email.
And so just so you guys know, Rusty's email is up at the top of that sheet, way up here. rbowers@fortbend.k12.mt.us. Does that look correct to you, Rusty?
Yep, it looks good.
So you guys have a lifeline. You can reach out to Rusty if you need some help. Our next intersections is going to be November 9th, and we're still kind of playing with the format with this to see, make something that people will really like, people will make it useful to people. And so if you have any feedback, please email me. My email's up at the top of the screen too, up at the top of the document. And then we need to pick a topic for next week. So I know that Jennifer had to log out. Somebody else had to log out because they were having difficulty connectivity issues. But do you guys have any topics you'd like to talk about for our next session? You can go ahead and type it in the Google Doc, or you can speak out if you have a microphone on you.
What did Jennifer talk about last time?
She talked about standards-based grading.
Oh man, I'd like to see that one.
Oh, well, you know what, Rusty? You're in luck, because you can log into the GeoGebra, or to the hub, and you can actually go back and see that video. And so, that video I think I did not edit just because time was a factor, but this one we'll clean it up, we'll get it edited, we'll have this thing up there so you can share this with anybody else that would be interested. We'll pick a new topic for next, I guess it'd be November 9th at 3:45 p.m. and we'll have a new guest host, and so I'd invite you guys all to come back. If you'd like to earn your renewal units, you can see that information up there on the screen. Right here, just log into learninghub.mrooms.net. You can log in, go self-paced courses, and then pick intersection. Just fill out a short evaluation, and we'll send you a renewal hour. So thank you guys for your time. Are there any questions for myself or Rusty before we close the meeting? All right, well, great. Thank you for another great session of Intersections. Hope you all have a great month, and we'll see you back here November 9th at 3:45 p.m.